हरि करना।
So as we in the evolution of the F distribution in statistical analysis, so now it's time to build a F distribution from scratch. So this is a step-by-step guide to build the F distribution from scratch. So suppose we want to build an F distribution based on the ratio of course that's one technique, based on the ratio of two chi-squared distributions for two different samples of heights of two different groups, group A and group B. This is what the example we are taking. Then the steps to be followed: first one, choose the degrees of freedom for the numerator and denominator chi-square distributions denoted as df1 and df2 respectively. Okay, these are two samples now. Sorry, we have two samples separately which represent two different populations. So that's the reason you will have two different uh, degrees of freedom for the numerator and denominator. Then we have, once that is done, then you have to generate a large number of random samples from a chi-square distribution with df1 degrees of freedom. So once that is done, we have to generate a large number of random samples from a chi-squared distribution with df1 degrees of freedom. Same, you have to do it for df2 degrees of freedom. Once that is done, now you have to divide each sample from step 2 by the corresponding sample from step 3. This will give us a large number of F statistics. Once you got the F statistics, you have to plot a histogram of the F statistics. So this will give us an approximation of the F distribution with the df1 and df2 degrees of freedom. Once this is done, we will calculate the mean and variation of the F distribution. The mean is using this df2 divided by df2 minus 2, and then df2. So you have to use df2 if and only if df2 is greater than 2. And same variance, this is the formula for variance to calculate the variance. Okay, now let's do it practically. So this is our F distribution. The example that we're going to take here is we want to see, we want to apply this, we want to build an F distribution, we want to build an F distribution on the ratio of two chi-squared distributions for two different samples of heights. Let me check it in inches of different groups. This is very important. Of two different groups. That's where this F distribution makes a huge impact when it comes to data science. Two different groups. Let me name it as group A and group B. This is what is our example. So now let's begin. Step 1. So you have two different groups. From two different groups, you have two different samples of heights. Now we have to build an F distribution from this data. Let's do that. So first thing is to choose the degrees of freedom for the numerator and denominator. A chi-squared distributions. So let's denote them as df1 and df2 respectively. So let's say we choose df1 is equals to 5 and df2 is equals to 10. So this is for group B and this is for group A. So this is what the degrees of freedom. Obviously df2 is highest, which is also greater than 2. The degrees of freedom is high. So now let's move to the other step. So step 1, the degrees of freedom for numerator df1, for denominator both are done. Now let's generate step 2. Let's generate a large number of random samples from a chi-squared distribution with df1 degrees of freedom. This is for these df1 degrees of freedom. So for group A, let's say we generate 1000 random samples, not 1000 random samples. Okay, 1000 random samples of heights, and then compute the chi-squared statistic for each sample. Then we will get a mean height of 68 inches and chi-square statistic. After doing that, we got the mean height of 68 inches, and squared statistic. That's very important. Another important squared statistic. Square statistic. All we have done we have calculated uh, chi-squared statistic for each sample. Then we have summed it up. After summing it up, what we got is 30. That's what we got for this. So this is for the group A. Now let's get into the group B. So step 3. So again, let's generate a large number of random samples from a chi-squared distribution with df2, this time degrees of freedom. Okay, so now this is for the group B. So again, let's say we generate 1000 random samples of heights and compute the chi-squared statistic. So we got mean height of this group is equal to how much? It's 72 inches, and then chi-squared statistic for this group we got around 60. It's too much. That's okay, no issue. So that's what so df1 and df2's information is calculated. So now let's divide each sample. Okay, 1000 samples we have. How much we have generated? 1000 samples for group A and 1000 samples for group B. So now we have to calculate the F statistic. So now you have to divide each sample from step 2 by the corresponding sample from step 3. That's nothing but the group A with the group B. So this will give us a large number of F statistics. So we'll get the large number of F statistics. So that is equals to, obviously, in our case, we will divide the chi-square, the statistic group A. That's a group A chi-squared statistic of group A divided by chi-squared statistic of group B. Hence, we got the value of, obviously, 30 divided by 60. How much you will get it? Tell me. It's 30 divided by 60. The value is equals to 1 divided by 2. That's 0.5. So this is what my F statistic. This is called large number of F statistic because that's how we have calculated. So now once this is done, the next step is pretty straightforward. Step 5. So this we have done it for one sample. Similarly, you have to do it for the every sample. After doing it for every sample, you will get an F statistic for each and every sample. So you will have 1,000 F statistics. 1,000 F statistics. So now we have to plot a histogram of the F statistics. So finally, this will give us an approximation of the F distribution with DF1 and DF2 degrees of freedom. Let's say we plot the histogram and get a distribution that is skewed to the right. That's what we'll get it. Okay, and then with this, everything is done. But as a final nail in the coffin, so the final step would be just calculate the mean and variance of the F distribution, overall F distribution. Okay, so for that, the formula that we can use is same. Mean is equals to df2 divided by df2 minus 2. So for us, it's 10 divided by 10 minus 2, it's 8, is equals to 1.25. That's what is our mean. And then variance is equal to 0.79365. So that's what is the mean and then variance. So this is the manual way of doing. So now what will we do is, so note that the most important point to be remembered here is mean and variance are only defined for df2 greater than 2. In our example, df2 is equals to 10. That's what we have specifically taken, df2 which is greater than 2. Even df1 is also greater than 1, but this is only for df2, based out of df2. Okay, so df2 is equals to 10, which satisfies the condition. So mean and variance, you have to calculate. The condition to be satisfied is that degrees of freedom should always be greater than 2. So here in our case, df1 and df2 both are greater than 2, but anyway, we always go with the df2 and df2 which is greater than 2. So that we have used to calculate the mean and then variance. So now let's do the same. Because here we can't simulate everything because the 1,000 samples and also that's why we'll use NumPy and PyPlot to simulate this. Let's do that. So import NumPy as NP. Then we also import matplotlib.pyplot and as plt. So that's it. Now it's time. Step 1, set a degree of freedom. We are using the same data. Okay, so df1 is equals to 10. Sorry, df1 is equals to 5. Degree of freedom 2 is equals to 10. Then next, so step 2 is to generate random samples. Same step. Let me copy this, or no, let me copy this directly from here. So let's generate a large number of so sample 1 for the group A is equal to np.random.chi-square, and obviously from df1 I want to have this many number of samples, 1. Okay, so done. So these many samples I want to generate, I gave. So next, step 3, step 2 is done. Step 2, next step 3. So same thing with the group B. Same thing we'll be doing with the group D. Yep. So sample 2 is equal to np dot random dot chi-square, and this time I'm gonna show df2, and I'll go with these many values. So now I'm gonna show you what is sample 1. Sorry, markdown, just going to markdown. Okay, sorry. Why sample 1? See that you got the array of chi-square statistics. These are all chi-square statistic. You see that we are using chi-square method. We gave the df. When you have a df, degrees of freedom, and then you have a sample of data, then obviously we want to calculate with this degrees of freedom and with these many statistics, sorry, these many chi-square statistic. And you see that the shape ones, tens, hundreds, thousands, 10,000, lakh. So 1 lakh sample, that's huge. So same thing we did with the sample 2, and we have generated 1 lakh chi-square scores. You see that? Huge, brilliantly huge. Anyway, so the second step and third step is done. So the chi-squares has been generated. Now it's pretty simple. Step 4 is just calculating the f statistics. Calculate f statistics. That's it. So f underscore statistics is equal to sample 1 divided by sample 2. And now I'm going to show you f statistics. And these are all f statistics. You see that? These are all close now. 0.41, 0.76, 0.26. These are all f statistic for each corresponding chi-square statistic of the samples from group A as well as group B. That's it. Your f statistic is ready. Now nothing much to be done. Now you have to put it in, you have to calculate the frequency of each f statistic and put it in an histogram. Nothing else. Let's do that. So step 5. So plot the histogram f statistics. So plt.hist, and then it takes up f underscore statistics. Those are the values it will take. And how many bins? I'm going to go with the bins of 5050. Then density is true. Then finally alpha is equals to, what happened? Alpha is equals to 0.5. And this is your plot, but I don't want these values to be shown. And one more thing, there is no labels. Let me add the labels now. So plt.x label, I'll go with f statistics. That's what is there on x on x-axis. Then plt on y label. So on y we have a frequency. Then plt dot title. So I'll go with F distribution with df1 is equal to df1 and df2 is equal to df2. That's it, all done. Now it's time to just show it. Nothing else is left. So plt dot show, and here is your, so df1 is 5, df2 is 10, and here is your f distribution. Congratulations, we have made our own f distribution with the principles. So that's how it looks. It's obviously skewed towards right, that you can see. That's how it works normally. So now let me calculate. Let me go to the step 6 and finish it. Step 6, plot histogram of f statistics. So, oh, sorry, I'm sorry. So step 6 is we need to calculate the mean and variance of f distribution. So mean is equals to df2 divided by df2 minus 1. Sorry, 2 minus 2. Sorry. And then variance is very complicated formula. So let me give into this. Okay. So anyway, the variance that's enough. Let's see. Yep. So let me print the mean. So because it's gonna take more time, let me print the mean. That's more than enough. So mean. Yep. You got the same value, 1.25 here, and this is what is your f distribution. So the code, this whatever we have done, this generates whatever code that we have used here, sample 1 and sample 2. This generates a random samples from chi-square distributions with degrees of freedom df1 and df2, calculates the f statistics by dividing the two samples and plots a histogram of the f statistics. Finally, it calculates the mean of the f distribution.